Hello fuckers, another day, another math problem. So, we choose 51 numbers, different numbers, from 1 to 100 and order them increasingly in a list. We call that list A. Got it? Can't repeat. So, here we have a list of 51 integers ranging from 1 to 100, where all are different and we have ordered them to be increasing. And the problem is prove that there exists an element in this list that is the sum of two previous elements. How do we prove this? We will prove this by the so-called pigeonhole principle. If you don't know what the pigeonhole principle is, I will give you a quick recap. So basically what it says is, if there are more pigeons than there are pigeonholes, then pigeons are gonna have to share pigeonholes. That's basically it. Yeah. That's the correct mathematical definition. And yeah, that's what we're gonna use. So, to do this, I will kind of assume that there exists an element which is the sum of the first element plus something else. One could almost assume, or at least think, that it's easiest to create a sum of the first one, because that's the smallest, and therefore there are more choices, more to choose from, like which one you want to create a sum with for it to not exceed 100. So I'm just going to assume we're going to create a sum with the first one. So therefore I'm going to create the list S, which is the piecewise element-wise subtraction of A and A, the list A and the element A1. So therefore the first one would just be A1 minus A1. So, and we scrap that, we remove that. So we just have A2 minus A1, A3 minus A1, and so forth, all the way up to A51 minus A1. So that is our list S. And now we must note, as we did previously, that all of these are different. All the elements in this list are different, and all of these are also different. And this list contains 51 elements. This list contains 50 elements. If we then so-called concatenate these two lists, meaning that we create a new list, I call it T, which is just all of the first ones all of the elements in A next to all of the elements in S. So we just have A1, A2, all the way up to A51, which is just the list A, and then we just write down all the elements in S. So A2 minus A1, and yeah, you get the point. So forth all the way up to A51 minus A1. And now, okay, so here we have 101 elements. And now we must look at what values can these elements obtain? What values can these elements have? Well, in A, we said that, okay, the values can be between 1 and 100. And if we're subtracting something between 1 and 100 minus something that is less and between 1 and 100, then we can get something in between 1 and 99, if I'm not correct, which is contained in the interval 1 to 100. So therefore we could say that this list contains numbers ranging from, this list here, T, contains numbers ranging from 1 to 100, but it contains 101 elements. And here comes the pigeonhole principle. Now there are more pigeons than there are pigeonholes. So 2 pigeons at least are going to have to share a pigeonhole, meaning that there are 2 duplicates here. 2 of these elements are the same, and since we know that 2 elements in the first half can't be the same, because that's what we stated before, and the same holds with the second half, or sorry, not the second half, but the first 51 and the last 50. No element within this range, or this part, can be the same, as we stated before. Therefore, there has to be a pair in between these parts, meaning that there is an element in the first 51, that is equal to an element in the last 50. So therefore, there has to exist a, let's call the indices, okay, maybe M and K, such that, okay, M is the index of this part, and K is the index, but yeah, exactly, it's the index and then minus 51, because here, as it says here, it's okay, it's a2 minus 1, and then it's a51 minus 1. So here we want this number, really, we don't want 101. So it's the K is therefore the index of the second element in the pair, minus 50, and M is the index of the first element in the pair. And therefore we then denote that AM is equal to AK minus A1, which is equivalent to AM plus A1 being equal to AK. And here we have that the sum of 2 elements is another element in the list. Or do we? Because actually there's a flaw in my proof, or at least a case we're disregarding. What is this case? You tell me. So yeah, so in this video I will not say proof concluded, because it is not, and the challenge is up for you, and I would be very glad if you would find the missing piece and maybe even salvage it and fix the plot hole, sorry, fix the plot hole. So yeah, that was everything for me. Hope you're up for the challenge. Good luck, and see you some other time. Bye bye.